Hi everyone, I'm Sang Kim. Today I have prepared an interview with Tom Brown. I used to work with him at Tesco Korea in site research department. Currently, Tom is working for a data-driven company to help many clients. The company name is Local Gravity. Local Gravity provides retail and demographic data, systems, and best practice consultancy to help retailers develop data-led strategies to expand their store networks. I hope you enjoy watching this video and please click like and subscribe for further information. Thank you. Okay. Hi Tom. Thank you for giving me a chance to have an interview with you today. How are you today?
Very good, very good.
Okay.
No, I would say sunny Jeju, but it's actually rainy Jeju Island today. Very
Right.
nice, South Korea.
All right. I hope you enjoy your life at Jeju Island. All right. So the first question, could you introduce about your working experience and also your current company, what you do for a living? Yeah.
Yeah, sure. Yeah, so my background is in analytics. I studied maths at university and did a master's in operational research. And then in the last 25 years now, I've been working in retail and really focused on store location planning, so where to open stores. And so I worked for a long time with the British supermarket chain Tesco, first in the UK and then out in Asia, for the majority of my career, so in South Korea and in China, both those countries setting up a team to do what we call site research, so analysing strategy for where you can open stores, and then when there's a site opportunity comes along, doing sales forecasting, so how much sales can a store expect if you open in this location. And with Tesco, we were opening 10, 20 stores a year maximum, but each time you're investing millions of dollars, so you need to make the right decisions there. Then I moved to Adidas, a sports company in China, and they're also being in charge of the store expansion and the store expansion strategy. But here we were opening 1,000 stores a year.
Wow.
So very different scale of things. Mainly franchise business, so opened by franchisees. And there it was trying to use analysis and data to set the overall strategy of how many stores to have in each city, what are the right locations, where should we be investing more money in opening stores, where to close ones as well, because it's just a big numbers game. And then the last 5 years, I've joined a small consultancy called Local Gravity. We're based in China and cover Southeast Asia. And we supply data and tools and consultancy for retailers to do their store network planning. So we're working in all types of sectors, like we work with McDonald's and Starbucks, with Nike, with H&M, with Innisfree, so all different sectors, providing them tools about where to open. So for each of these, you're trying to do the same thing, which is what is the right store format to open in the right location. Mm-hmm. But for different sectors of retail, the key factors are a bit different. So just for example, with a supermarket, you want to be where the people are, but you don't want to have competition. You don't want to be head to head with another supermarket. That will just split the sales. But with, say, a fashion outlet or a sports outlet, actually you want to be where the others are. So if you are in a good shopping mall which has all of the major brands there, that attracts most consumers, and actually you do better there rather than sticking yourself on your own, trying to be the only shop to go to. So what's been interesting is understanding the different factors you need to look at for different types of retailing.
Okay. So you must consider lots of data to find out good location and for like site research work. So as a second question, could you share what kind of analysis do you do most for your business?
Yeah, so so probably the more complex things we do, sort of the end result of what we're trying to do is building a forecasting model. So if, with all of this data, with these factors you look at, what is the sales you can expect from a certain location.
Mm-hmm.
But we do a lot of steps to build up to that. So a lot of it is just simple understanding of the data and simple relationships, trying to understand which factors are the relevant ones. We do some segmentation analysis,
Mm-hmm.
trying to say, well, can we see patterns where there's different types of shopping mall or different stores which behave in a similar way to each other, but actually different from the different sets? Also, with consumers, can we put consumers into different segments which are helpful for then understanding how people behave or how a business should be marketing to them? Mm-hmm. I would say actually the level of sophistication of the models that we do doesn't have to be that difficult. And I've actually, over the time I've been working, I started with Tesco where we did quite sophisticated modeling, where we had a lot of data. And as I said, each investment costs a lot of money. So we were doing something called gravity modeling, mm-hmm. which looks at how the strength of different stores attracts people from the geography around it to share out the spend that each household has. But these days, where I'm doing quicker models and with less data or less quality data, then it's usually more regression type modeling.
Okay. Yeah. So, in summary, you do analysis for like sales forecasting, right? So, in order to do like sales forecasting, data quality is very important, right? So, could you like share your like thoughts about data quality management? How we can manage data quality in a better way? Yeah, please.
Yeah. So this is a very important one for me. And my experience is in the real world, you'll never find a perfect data set. So any data that you get, that you buy, that you collect yourself, you need to be skeptical about it and do quite a lot at the beginning just to check that the data is doing what you think it's doing and that the quality is right. So whenever I get a new data set, I start with a point is there's going to be something wrong with this. So let's have a look at it. So you just start doing the simple things. So, data set, just sort it from the highest value to the lowest value. Have a look at those top values. Do they make sense? Quite often you have a top value which is 10 times or 100 times bigger than makes sense, and it's because whoever inputting the data has just put the decimal place in the wrong point. It's very easy to do, and it happens a lot. It's surprising. Mm-hmm. And also looking at those extremes, are the data points up at the top or the bottom, are they the ones you would expect to see there? If in my case, a lot of the time we're looking at, say, shopping malls as the data points, and we have a lot of different data sets for it. But are the ones that we're seeing that have the highest traffic or the highest sales turnover, are the ones that we expect to see there? That's just a simple way of looking at the data to say, does it fit with my previous expectations? Mm-hmm. And where it doesn't fit with your previous expectations, there's sort of two possibilities. One is the data's wrong. Yeah, it's often the case. There's a problem with the data. The second one is your expectations are wrong. Mm-hmm. And then digging into that and actually trying to understand what it is also a very important part of learning. Mm-hmm. So if you're expecting, your previous expectation was actually wrong versus what the data is telling you once you've checked the data quality, mm-hmm. then that's changing your perception of the world, and that's a very important learning one. And I think those learnings are as important as anything that comes out of sophisticated analysis. Then the other simple thing I do is do just some scatter plots. Mm-hmm. So if you've got one variable with the new data plotted against another set of data where you expect there to be some sort of relationship, either a positive one or a negative one, have a look at that scatter plot. Does the shape, does it show that there's a very strong relationship or a weak one? Mm-hmm. And again, within that, look at the outliers. Look at the ones which are not behaving like the rest. And again, try to understand why that's happening. So, and again, it can be because the data is wrong for one of the data points, or it could be that this is an exceptional data point, an exceptional model for some reason. And again, understanding what's happening there gives a lot of understanding about the data and really helps you there. Just want to share with one example of what we've been doing recently. So in China now, there's a lot of big data become available, which is really exciting for me because this is all around consumer traffic and where people are and where they move. And that's always been a big challenge to get good quality sort of population data. But these days with mobile phone device tracking, you're able to pick up on where people are and where they move around. And this is then very powerful, obviously, to do anything around potential for a certain location, knowing how many people are there and something around their demographics is very helpful. And we've got we're working with some of the big data companies, paying a lot of money to get hold of this data. And what we found is we've had to do a lot of data cleaning ourselves. So what we want is, here's the shopping mall. We have the outline of the shopping mall, and we want to know over a month period how many visitors are there to the shopping mall. And then we look at that data and we compare it with other shopping malls. And what we found was that there's a lot of background noise happening. And so when you look at the traffic over the day, obviously you have a big peak during the main shopping hours, but even when the shopping mall is closed, there's still significant traffic coming through. And the reason for this is the way they pick up the data, the accuracy of the geo coding is not good enough to say, is that person really in the shopping mall, or are they just going past the shopping mall? So if you have a mall next to a busy road, it's picking up a lot of passing traffic. And so we've spent a lot of time then doing our own data cleaning to try to remove that background noise so that then the traffic data that we have is really representative of people entering the mall. And we found that the relationship we have between the performance data we have in the shopping malls and traffic with the raw data was about 49% R squared, so which is not bad. So for one, so it's so basically half the variation is explained by the factor. But once we cleaned the data, it went up to 61%.
Wow.
Which is a big difference. Yeah, and this is expensive data being sold by big data companies as this is traffic data, but just this extra work doing it made it a much more powerful variable that we can use in our analysis. And that's that work. It took a lot of time, but I think the value of it is pretty impressive.
All right. So, it sounds like to do good analysis, we need to consider exploratory data analysis as one of the important process to get very good quality of data, right? So
absolutely.
Yeah.
Absolutely.
So for these YouTube subscribers, actually, I want to share some tips and advice who want to be a data scientist. So could you share your tips and advice for someone who want to be a data scientist?
Yeah, sure. I think the first one I would have is show real interest in the data and the real world aspect for it. So and that's what I've always enjoyed about it is you're doing analysis with numbers and nice techniques, but the data comes from the real world and understanding what is happening in the real world. So for example, in my field where we're doing a lot of analysis about store location and shopping malls or stores, I always tell my team, go out and visit a lot of these places. So if you have a good understanding of the different shopping malls that you're doing analysis on, when you're then looking at the data and you're seeing some patterns happening, you can link it back to, okay, I know this shopping mall, I know it's a little bit different because it's on top of a subway location. so it has a lot of traffic coming in, and or there's a university next to it. But if you visit these things, then you'll have that understanding. So when you're looking at the numbers, the patterns will make more sense, or you're more likely to be able to interpret them in the right way. Mm-hmm. So I think having that, or for example, if you're working and doing analysis around factory and how they work and optimization, go down to the factory floor, look at how it's working. Mm-hmm. Don't just sit in your room with your computer. Go out and visit and try to understand the real world situation. Mm-hmm. Or if you're doing routing deliveries, go in a van and go with the person who's actually doing the delivery, and you can understand what it's like there. So that then when you're using the data to try to optimize routes and stuff, you also understand what it's like for the person doing that kind of work. Mm-hmm. So that would be one piece of advice. And then the other one would also be, because I've seen it happen a lot, is don't get lost in the data. So it's very easy when you've got a project, you've got your data sets there, and you're doing analysis, and maybe you're doing multiple regression and things like that. You're putting all the data in, and you've got your head down, and the output comes there, and you say, okay, here's the output, and you give it to somebody without really, again, thinking through, is what's coming out, is it sensible? Does it make sense to me? Can I explain why these two factors are related? Mm-hmm. And what I've often found, because the analysis I'm doing doesn't have so many data points. So we're doing analysis for a shopping mall location, and we're looking. So you might have 100 shopping malls, or even 1,000, but it's not a massive number of data points you're doing the analysis on. With regression, you always need to be careful, because if you're looking at 50 variables and 100 data points, the fit can look very good, but actually it doesn't make sense. So you might be saying, okay, more population means lower sales. Mm-hmm. That's happened before. And unless you look at it and say, well, does that really make sense or not? You end up coming to the wrong conclusions. Mm-hmm. So always, I think, challenge what the models are telling you or what the analysis is telling you. Don't always just take it, oh, I've done this nice technique, so the output is correct. Mm-hmm. But I think those are the two things. I think they're all related to trying to make sense of what you see and relating it back to real life.
All right.
Yeah, and then because when you're presenting or passing that on to somebody, they'll be able to see, particularly as a business manager, they'll be able to see it from the practical point of view. Mm-hmm. And if the data's telling you something funny, make sure you understand why and you can give an explanation.
Okay.
Or if you don't, if you can't explain it, think twice about sharing the output, because otherwise you get put on the spot and don't help the reputation of yourself or your team.
Okay. All right. So Tom, thanks for having 15 minutes interview today. I hope you enjoy your life at Jeju Island, and once you come back to Seoul, I will see you soon. Thank you.
That'll be great to catch up. Okay, nice to talk to you, Sangwoo.
Okay.